Today we're going to be talking about factoring trinomials, but before we begin that, I need to refresh your memory on something we've done a little while ago. So recently we talked about given a rectangle, and if you have the length is x plus 3 and the width is x plus 1, how would you find the area? So you know that area equals length times width, but in order to multiply these, you needed to use the box method, to where you put x plus 3 on either the top or the side, and then you put x plus 1 on the side to multiply in and then get my area. Well, today we're doing exactly the opposite of that. Today, you're going to be given an area. So this is like the area of your rectangle, and you want to find the length and the width. So in order to do this, we have to follow a process. It's the backwards box method. So your first step in order to find the length and the width is to create a chart. And what we call this is our multiply add chart. So what you need to do always, this is the rule, is multiply the first and the last term. So multiply x squared times 20. So multiply 20x squared, that's what you get when you multiply those two. So you're looking for two numbers that multiply to 20x squared, but add always to the middle term. So add to 9x. So what you need to do is create yourself a chart. So what you're looking for is two numbers that multiply to 20x squared, but add to 9x. Well, first of all, you need to think, what are my multiples of 20? So I would just list them, starting from the easiest and working our way up. So I know 1 times 20 is 20. I know that 2 times 10 is 20. 3 does not go into 20 at all, so I don't need to list 3. And then 4 goes into 20 5 times, and that brings me back to my loop, because my next thing would be 5, but I've already got 5 on the chart. So I've got my multiples that equal 20, but it's got to equal 20x squared and add to 9x. So the only way I'm going to get x squared is if I have an x times an x. And that's the only way I'm going to be able to add these two guys to equal 9x. So is 1x plus 20x equal to 9x? No, that equals 21x, so that's not right. Okay, 2x times 10x, or excuse me, 2x plus 10x is 12x, which is not what I want. I want 9x, so that's not right either. So the only one that I have left, and cross your fingers, is 4x plus 5x. Does 4x plus 5x equal 9x? Well, yes it does. So these are your special numbers. Okay, and so what you're going to do with those numbers is we are going to put them in the box. So how this works is this first term always goes in the first box. So I've got x squared. This last term always goes in the last box. It's a positive 20. Okay, and the 9x, since I've got two boxes left with only one term, what we just did is we broke that 9x up with our special chart that gave me the correct special numbers that go in there. So your 4x and your 5x add to 9x, that's what goes in the two boxes in between. And I hope that you would ask me, does it matter, Miss Garcia, which order they go in? And no, it does not. You could put the 4x first and the 5x second, or you could have done it vice versa. You will end up getting the same answer. So what you're going to do now is we've got the insides of the box. We need to know what goes on the outsides. What's our length? What's our width? Okay, and how you do that is by finding the GCF, so something we've done recently. So what is the GCF? What does x squared and x have in common? Well, what they have in common is x. What is the highest number that 4x and 20 have in common? Well, yes, they have in common 2, but you can go higher, right? They've got 4 in common. And I get my sign right here from this box. That's a positive 4x, so that becomes a plus right there. Likewise, I get the sign in between here from this box. So if that's a positive 5x, that means my sign in between is going to be plus. Okay, so across here, my GCF is x. Okay, that's what they have in common. And across here, the highest number those two guys have in common is 5. So to double check your work, multiply back in. Does x times x equal x squared? Yes. Does x times 4 equal 4x? Yes. Does x times 5 equal 5x? Yes. And does 5 times 4 equal 20? Yes. So we have done everything correctly. Our length and width would be x plus 4 and x plus 5. So let's try one a little bit more difficult. So number 2. Number 2, I've got 2x squared minus x minus 6. So my first step, I'll remind you, is to multiply my first and last term. So 2x squared times negative 6. So on my multiply chart, 2x squared times negative 6 would be negative 12x squared. So I'm looking for two numbers that multiply to negative 12x squared and add to negative 1x, or negative x. So you need to think of your multiples of negative 12x squared. So my multiples of 12 are 1 and 12, 2 and 6. So I'm just going down the way, 1, 2, 3, da 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 da. So 2 and 6, 3 goes into it 4 times. That starts me back over because I've got 4. Okay, so here you know they all have an x attached. So here's what's special about this. On this one, I've got a negative. It's got to multiply to a negative. What is the only way that two numbers multiply to give you a negative? Okay, they can't both be positive. They can't both be negative because a negative times a negative equals a positive. So the only way is for one of them to be positive, one of them to be negative. So either way, let's think about it this way. If 1 was positive and 12 was negative, that would give me negative 11x. That's not negative 1x, okay? Flip it. If 1 was negative and 12 was positive, that would give me positive 11x. So neither of those work, okay? So what if I were to say negative 2x and positive 6x? That would add to 4x, and if I switch the roles and make that positive and that negative, that would give me a negative 4x. Still not what I want. So if I make 3 negative and 4 positive, that would add up to 1x, getting closer, okay. If instead I make the 4 negative and the 3 positive, then that would add up to negative 1x. Okay, so it's got to be that the 3 is positive and the 4 is negative, because 3x times negative 4x equals negative 12x. But when I add 3x minus 4x, it equals negative 1x. That's what I want. I want negative 1x. So here are my special numbers that add up to negative x. Okay, those are the numbers I put in my box for my box method. So remember that you always put this first term, 2x squared, first box, last term, negative 6, last box, and then these special numbers in the boxes in between. Okay, so now check for those GCFs. 2x squared and negative 4x. I can take a 2 out of both of those, and I can take an x out of both of those. Okay, my sign here in between always comes from this box. This box is positive, I put a plus. Biggest number I can take out of these is 3. Okay, going across here, 2 and 3, there's nothing I can take out of that number-wise, but I can take out an x. And this sign comes from this box, which is negative. So that means I need a negative sign in between. So here, 4 and 6, highest number I can take out of that is 2. So again, double check your work. 2x times x is 2x squared. 3 times x is 3x. 2x times negative 2 is negative 4x, and 3 times negative 2 is negative 6. So your final answer for the length and width would be 2x plus 3 and x minus 2. So if I were to multiply those two guys by each other, I would get back to that problem.